Hi everyone, welcome back. This week in Science 9, we're going to be doing two short lessons. The first lesson is going to be on different types of compounds, and then the second lesson is going to be on naming ionic compounds, naming one of those compounds. What we're going over this week is compounds. Compounds are found all over. Most things you either use or eat or drink are actually made of compounds. So just to backtrack a little bit, a couple weeks ago we talked about what matter is. Matter can be broken down. It could either be a pure substance or a mixture. So we don't deal with mixtures in Science 9. Pure substances, they could either be elements, so pure elements such as like oxygen, hydrogen, or they could be compounds, which we're going to talk about this week. Now, what compounds are, they're actually things that are made of more than one type of element. So things like water, which is made of oxygen and hydrogen, um, table salt, NaCl, sodium chloride, a lot of things we use, most of what our body's made up, are made of compounds. So remember, elements, they're one type of atom. And like I mentioned earlier, compounds are made of two or more different types of atoms that are joined together. And that's called bonding when they're joined together. So here we have atoms, and then we see compounds, also called molecules. They could be made of two or more different types of atoms, or they could be made of two of the same type of atom that are joined together. So atoms form bonds with other atoms and they make compounds. And the reason they do that is so that both atoms in the molecule will end up with a full outer shell of electrons. So it benefits both of them. And that's why we don't see very many single elements in nature by themselves. They're usually in compounds, especially the reactive ones. So we saw a couple weeks ago what happens when sodium is dropped in water. It would explode. So pure sodium wouldn't last very long just outside. So it's usually in a compound like or table salt, NaCl. So sodium is really dangerous. Chlorine by itself is really dangerous, but when they're together, they're perfectly fine. So I'd like you to pause this video and watch this video link here. It's about 5 minutes. Cool little animation on the difference between atoms and molecules. And then once we're done that, we're going to go over the two different types of compounds and the two different types of bonds that hold those compounds together. So the first one we're going to go over is called ionic bonds, and they are what hold ionic compounds together. So an ionic bond, going back to what we did last week, it's when two different ions, two or more different ions, bond together. And how these bond, it's a bond between a metal and a non-metal. Remember, we talked about last week how metals will give away a valence electron, one or more, so they have a full outer shell, and this gives them a positive charge. Well, they give those electrons to nonmetals. So you see right here this little blue electron. The nonmetal takes it, and the nonmetal gets a negative charge. So the valence electrons are transferred. Once that happens, there's an attraction between the positive charge and the negative charge. So they're held together by an electromagnetic force. So an example of that is sodium chloride, NaCl. And that's an ionic bond. And these are way stronger than the next type of bond I'm going to talk about, covalent bonds. Covalent bonds are between two or more nonmetals. And instead of an electron being transferred from one atom to another, they actually both share some of their valence electrons with each other. So this example right here, hydrogen and fluorine. Hydrogen has one valence electron, and it needs one more. Fluorine has 7 and it needs 1 more. So they both share 1 electron with each other. So they both have a full outer shell. So just a little bit more information on ionic compounds. So ionic compounds, the metal loses an electron. Non-metals take the electron. They make 2 ions that are attracted to each other because they both have full valence shells. One's positive, one's negative, and that's how an ionic bond forms. So we're going to talk more about this next week when we go into writing formulas for compounds, but we're going to see some patterns here. So one of the patterns we're going to see is group 1 elements. So like lithium, sodium, potassium, they have 1 valence electron. And group 17 elements, so like fluorine, chlorine, bromine, they have 7 valence electrons and they need 1 more. So a lot of times these make good pairs with each other. So the alkali metal will donate an electron to the halogen, and then they'll form a pretty stable ionic compound. Group 2 elements, so the alkaline earth metals like magnesium, they want to give away 2 electrons. So one of the groups they pair up really well with are the group 16 nonmetals, because those group 16 elements, they need 2 valence electrons. So in this example right here, magnesium gives away 2 valence electrons to oxygen. Magnesium has a charge of +2, oxygen has a charge of -2, and they're attracted to each other. Another option for the group 2 elements like magnesium, they need to give away 2 electrons. They could also give away 1 electron to 2 different atoms. So group 2 elements can also form bonds with group 17 elements. So this example here, we see magnesium with 2 chlorines, MgCl2. So this magnesium will give 1 valence electron to this chlorine. This chlorine will be a -1, see right there. And then this magnesium will give another valence electron to another chlorine. So this chlorine will be -1. And then because this magnesium has given away 2 electrons, it has a charge of +2. And you'll see that with other combinations as well. Couple memes for you. Okay, and then next we're going to talk about covalent compounds. So remember, covalent compounds are where there's 2 or more nonmetals and they share valence electrons, so they all have a full outer shell. So I've mentioned this already, but like hydrogen has 1 valence electron and it needs 1. Fluorine has 7 valence electrons and it needs 1. So they pair up and they both share 1 electron from their outer shell and form a covalent bond. In some examples here, like we see with water, water is a covalent compound. Oxygen needs 2 valence electrons, so it shares 1 with 1 hydrogen and 1 with another hydrogen. And these covalent compounds can get pretty complex. We're not going to deal with them in Science 9. I just want you to know what they are. Covalent compounds are compounds where nonmetals share electrons. Here's some more examples of covalent compounds. We see methane, carbon dioxide, NH3. And sometimes covalent compounds can form what's called diatomic molecules. That's when 2 or more atoms that are the same type of atom bond together. So the oxygen we breathe, it's actually not just a single oxygen atom. They're actually 2 oxygen atoms bonded together as a covalent compound, and those are called diatomic molecules. So we see that with oxygen. We also see that with the nitrogen we breathe. We see that with hydrogen gas. A couple more memes. And then the last thing we're going to talk about, this is more extending stuff. You're going to see these in when we get to naming later this week, but polyatomic ions, what those are covalent compounds. But overall, the compound is either missing an electron or it has too many electrons. So overall, the compound will have a positive or negative charge. So, and they're all given special names. So this one right here, carbonate, CO3 2 minus. So it's one carbon that forms covalent compounds with 3 oxygens, but they have 2 extra electrons overall. Phosphate, one phosphorus forms covalent bonds with 4 oxygens and they have 3 extra electrons. Nitrate, ammonium, like I said, you're not going to need to know this stuff. This is more extending stuff. We are going to deal with these when we get into naming, but that's all you'll need to know about these. So what I'd like you guys to do, I'd like you to watch this first video. It's a great song, Ionic and Covalent Bonds. And then if you need some more help with this stuff, there's these 2 helpful videos right here. So that's it for the end of this video. If you want to kind of break the assignment, the worksheet up into chunks, this video covers the first 4 pages of the worksheet. So if you want to get started on that, I'll show you right here. First 4 pages. So compounds, fill in the blanks. There's a true and false part. There's a part where you there's letters A to L, and you put what applies. If it applies to an ionic compound, you'd put, say, A. If it applies to covalent, you would put A in there, or if it applies to both, you'd put A in there. And then the little quiz at the end. So that's it for this video. I'm gonna get you to watch the next video when you're done this as well on compounds. I'll talk to you guys soon.